three salts, that is caustic soda we have discussed. We have discussed baking soda and we have discussed bleaching powder. Okay, the remaining two are the plaster of Paris. One is plaster of Paris. Okay, plaster of Paris. That is calcium sulfate hemihydrate. Okay, and calcium sulfate hemihydrate. So if we talk about what is calcium sulfate, let's we talk about this one. Okay. Calcium sulfate hemihydrate. So calcium sulfate, how it is prepared? Let me talk about this one. That is calcium sulfate dot 2H2. Okay. Before discussing this one, let me discuss that what is this dot 2H2. Okay. So there is a what this is called water of crystalline. What is water of crystalline? Water of crystalline. What is water of crystalline? The loosely attached water molecule. The loosely attached water molecule per unit formula of the compound. Per unit formula of the compound. Okay. So it is a loosely attached water molecule. Some crystals, some salts have the loosely attached water crystals. Okay. And this is called loosely attached water molecule. Okay. For example, like copper sulfate, CuSO4.5H2. Okay. Okay. This is called blue withdrawal. Blue withdrawal. Okay. Cu. This is copper. Cu, not Ca. Okay. CuSO4.5H2. This is CaSO4.2H2. What it is called gypsum. Gypsum. FeSO4.7H2O. It is called green withdrawal. Green withdrawal. Understood? Note it down fast. Put it down.
Done, sir.
Next is MgSO4.7H2O. This is called Epsom. Because ZnSO4.7H2O. This is called white withdrawal. White withdrawal. Okay. Next one is Na2SO4.10H2O. And it was this is called washing soda. Washing soda. Washing. Okay. And plaster of Paris is CaSO4.half H2O. This is PO3, plaster of Paris. Note it down.
Completed, sir.
You also be? You also? Veer, are you there? Abir. It is there, but mic is not connected. Okay. So this is the water of crystalline. Loosely attached water molecule per unit formula of the compound. That is called. Okay. Now moving to the next point here. We are just talking about this is why it is called water of crystalline, because it gives the crystal, the shape of the crystals. Okay. They are the different shapes of crystal, like tetrahedral shape, like bipyramidal shape. Okay. a pyramidal shape, trigonal, bipyramidal shape. There are different types of shape of the crystal. So generally, this water molecule is responsible for giving the shape of the crystal and the color to the crystals also. For example, this CuSO4.5H2O, it is green in, sorry, it is blue in color. Blue in color, okay? But if you heat it, CuSO4 when heated, at 5H2, which is blue withdrawal when heated, copper sulfate, at 5H2, when heated, it gives you CaSO4 plus 5 water molecule will evaporate. Okay, so this will become anhydrous copper sulfate, anhydrous copper sulfate, and it will gives you what? It will gives you white color. This is white color. Okay, white color substance. Now the color of blue color will changes to this is blue color. Okay, blue color. The blue color of copper sulfate is due to spots of crystalline. Similarly, FeSO4, the green withdrawal, dot 7H2O, ferrous sulfate, dot 7H2O, heptahydrate. Okay, when it is heated, it will gives you FeSO4, and this water molecule, this 7 water molecule will evaporates. Okay, so this will gives you anhydrous ferrous sulfate, anhydrous ferrous sulfate, and it will gives you, it is white crystalline, means translucent, white translucent, okay, note it down.
Done, sir.
Now moving to the next part is, let me text wait the other students. Now moving to the next part here is, if we talk about this one, okay. Now next we are just discussing about plaster of Paris. Plaster of Paris. Plaster of Paris is formed. This is, I have told you that it is CaSO4 dot half H2. So how it is formed? When copper sulfate dot 2H2O. This is gypsum, sorry, calcium sulfate dot 2H2O. It is a gypsum. We have written this one named as gypsum. Yes, we have written this one gypsum. Okay, so this gypsum is a hard mass substance. Okay, when it is heated, when it is heated, it at controlled heat. It should be controlled heat. No, you cannot do uncontrolled heat. So the temperature should not exceed above 100 degrees Celsius or 373 Kelvin. 373 Kelvin. So when you heat it, it should be controlled heat. Controlled heat. Okay. So we can simply say that this will become plaster of Paris. Out of 2, the 3/2 water molecules will evaporate and half water molecule will remain with the per unit formula of the compound. Okay. So this is called plaster of Paris. Plaster of Paris. And this is gypsum. Got it? Got it?
Yes, sir.
Now what happens when if uncontrolled heating is done during, what happens when uncontrolled heating is done? Uncontrolled heating is done. It is asked in the examination that what happened if uncontrolled heating is done during the formation of plaster of Paris. So this gypsum, if you do uncontrolled heating, then heated uncontrolled heating. Okay. then this whole water of crystal will get evaporated. CSO4 plus 2H2O. Okay. Which this whole water of crystal will get evaporated, and this will become dead bond plaster. Okay, and this is hard mass, and it's called dead bond plaster. Got it? Got it?
Yes, sir.
So uncontrolling, and it is asked that what happen if plaster of Paris is kept in open air? POP kept in open air, then what is going to happen? This calcium sulfate dot 2H2O. This is POP. Half H2O means POP. 2H2O means gypsum. This CSO4 dot half H2O, when kept in open air, it will absorb the 3/2 water molecule from the atmosphere and will form again gypsum. CSO4 dot 2H2O. Okay, this is from gypsum, and this is hard mass substance. Okay, got it? So please note it down.
Done, sir.
Done. Abhi,
Done, sir.
so let me explain you this one. So this question comes in examination, you have to write it in this one. What would happen if uncontrolled heating is done during the formation of POP? So note it down. If uncontrolled heating is done during the formation of POP, okay. First of all, write the preparation in proper manner. Okay. Wait a minute. During the POP formation. Okay, you have written this one. Okay. Write down these two questions. What happens when it is kept in open air? In proper language. Note it down. When you're done, please let me know. Okay.
Done, sir.
You also? Shweta?
No, sir.
Done, Shweta? Hmm?
No, sir. 1 minute. Done, sir.
So uses, it is used to make decorative items like craft, okay? Item, it is used for fixing fractured bones, okay? It is used for making toys, it is used for making cars. Note it down. Note it down, please. Just why you are late.
I'm sorry, sir. I had some internet issues over here.
In the previous class, you were also late. I remember.
Sir, previous class I was early.
Was on time. So who was having internet issue?
Yes, I'll make sure to join next time early. Sorry, sir.
Okay. So we have studied about the plaster of Paris. Okay, noted everyone. So the students are noting. Let me explain. Plaster of Paris is CaSO4 dot half H2. This is another formula. In the previous class, we have studied bleaching powder, caustic soda, and the last one was baking soda. Okay. So now we have this plaster of Paris, and how it is formed? It is formed by heating calcium sulfate dot 2H2O, that is called gypsum, and it should be, it means temperature should be controlled here. You cannot heat it extreme at any temperature. Okay, if you heat it uncontrolled, then the whole of this water crystal will lose. Okay, but if you heat it at 100 degrees Celsius or 373 Kelvin, then only the water molecule only half water molecule will remain attached with this one, and 3/2 water molecule will lose this. Okay, so this is plaster of Paris preparation. Okay, got it. And if you uncontrolled, means if you are doing uncontrolled heading during this one, then what would happen? Then this whole water of crystalline will loses. Whole, this is called water of crystalline. This is a loosely attached water molecule, that is dot 2H2O, dot 5H2O sometime. Okay, like we have copper sulfate dot 5H2O. Okay, so if we heat it uncontrolled heating is done. Uncontrolled heating, then whole of the water crystal will loses and it will become dead bond plaster. It is called dead bond plaster. Okay, so note this equation fast.
Yes, sir.
Other student, have you noted the uses?
Yes, sir.
Yes, sir. Noted.
Okay, let's move further. Done. PhD noted these two equations.
Yes, sir. For now, I've taken the screenshot. I'll copy them down.
Okay. Now moving, write down this question. A copper sulfate, a sulfate group, a sulfate salt means sulfate is SO4. And salt means it can be Na2SO4, it can be CaSO4, okay, it can be K2SO4, it can be MgSO4. So sulfate means SO4 group, okay, of group 2 element, of group 2 of the periodic table, okay, means it is of group 2. What is group 2? You have seen the table, that periodic table, that the first group is called, this is with hydrogen, then lithium, then sodium, then potassium. Okay, and this is the another group 2. Group 2 element is beryllium, okay, magnesium, and then calcium. Okay, so this is group 2. This is group 1. This is group 2. So group 2 elements have 2 valencies. Group 1 element has 1 valency, like lithium has 1 positive 1 valency, sodium has positive 1 valency, potassium has positive 1, beryllium has positive 2, magnesium has positive 2, calcium has positive 2. Group 2 means, so if it is saying sulfate salt with group 2, so group 2 can be, it can be barium sulfate, magnesium sulfate, or calcium sulfate. Okay, got it? Got it?
Yes,
Yes.
So of the the periodic is white. It is white and soft substance, which can be molded into different shape by making it stone. Means you can mold it, you can frame it into different shapes by making it stone. When this compound is left open for some time, it becomes solid mass. Why it becomes solid mass? Because it absorbs the moisture from the atmosphere. Okay, so now you have you may have idea for this one that this can be calcium sulfate dot half H2O. When it is kept in open air, I have told you that when it's kept in open air, it will absorb the moisture 3/2 and will become CaSO4 dot 2H2O. That is hard mass. That is the hard mass. This is the hard mass substance, gypsum. Okay, you got it? Understood? Okay,
Yes, sir.
identify the sulfate salt and why does it show such a behavior? And give the reaction. So POP is a hygroscopic salt. The reason for this one is POP is a hygroscopic salt. Hygroscopic means that absorb the moisture and will not change the state. There are the two types of substance. Let me explain you. What is the difference between hygroscopic and deliquescent salts? Deliquescent and hygroscopic. And hygroscopic. Hygroscopic means substance will absorb the moisture and will not change its state. And deliquescent means the substance will absorb the moisture and will dissolve into this one. Like we have in the like sodium chloride. Okay, caustic soda is deliquescent in nature. It will absorb the moisture and will become sticky. But hygroscopic means it will absorb the moisture but will not dissolve, will not get sticky. Okay, so this is a hygroscopic salt which absorb the moisture from the atmosphere and form gypsum, which is a hard mass substance and cannot be used for molding purpose. Okay, so please note it down. Note this question. Note from here. A sulfate salt, okay, which can be molded. Don't write this to group 2 element. Okay. Okay, write the whole question. You can write the whole question. Note it fast. Done?
Done,
Yes,
sir.
sir.
Okay. Now let's move further. Now the another type of salt was let me explain it. That is washing soda. Okay, washing soda. Washing soda is sodium carbonate dot 10H2O. And how it can be prepared? By heating by heating sodium hydrogen carbonate. This is baking soda. Baking soda. Okay. When you heat baking soda, it will gives you Na2SO4 dot H sorry N2SO4 plus carbon dioxide plus water. Got it? Got it? Now this
Yes,
still
sir.
has
Yes,
10,
sir.
10 water molecules. So when you add it with 10 water molecules, okay. So when you add it with 10 water molecule, so it will absorb this 10 water molecule and form Na2SO4 dot 10H2O. So this is washing soda. Washing soda. Okay, note it down. Washing soda. And how you prepare if someone asks you that if you need to prepare
Done,
each and
sir.
everything, how you prepare so this sodium hydrogen carbonate? A reaction before this can also be written here in order to prepare that how this one is prepared. So you know that this is prepared by using sodium chloride plus water plus this is brine. Brine when added with ammonia, this is called ammonical brine, and then carbon dioxide. Then it will gives you what? It will gives you sodium hydrogen carbonate plus ammonium chloride. Got it? So this is baking soda. Baking soda and this form PPT, this form solid and this form PPT precipitate, so it can be easily filtered. Okay. Now this baking soda when heated, again I'm just writing the same equation. When this baking soda NaCO3 when heated, then it will give you Na2CO3 sodium hydrogen carbonate when heated. It will be sodium carbonate plus water plus carbon dioxide. Okay. And the next one is if you put this Na2CO3 with 10 water molecule, then it will gives you Na2CO3 dot 10H2. Okay, noted down. And same means you have noted this one, this right, and you have also noted this one. So no need to write it again. Just this is a preparation method that you know that how it is prepared. Okay, got it? Got it?
Yes, sir.
So if a question comes in examination that how will you separate? How will you separate or distinguish if you have a washing soda and baking soda both in a container? Then how will you let me have the same question. Wait a minute. To separate baking soda and washing soda by giving this question. Question number 37. Question number 37. What you will write the answer for this one? What you will write? How will you separate? By heating? Hmm? Any answer? You mean? So how will you distinguish? You know that baking soda when heated, it gives you carbon dioxide, but washing soda when heated, it will not give you the carbon dioxide. Okay. So when you heat baking soda, it will gives you Na2CO3 plus water plus carbon dioxide. Carbon dioxide is produced when you heat baking soda. But if you heat washing soda, no carbon dioxide gas will be released. Okay. No, this will be Na2CO3. Only the water of the sky will be evaporate. That's it. Okay. No carbon dioxide is produced. Got it?
Yes, sir.
Yes,
Okay.
sir.
So note it down that when we heat baking soda, carbon dioxide gas is produced. Done.
Done, sir.
Sir.
While when we heat washing soda, no carbon dioxide gas is produced. And write down these two reactions. Write down these two reactions.
Excuse
Here,
me, sir.
students, that yes,
For the chapter metals and non-metals, are we going to continue it after we have completed the revision for this? Because
yeah,
metallurgy is still left.
metallurgy you have not prepared now.
Yes, sir. And the extraction part.
Extraction part. Okay. So hopefully, I think other students, every student is going to have this metallurgy portion. This syllabus. Yes, we should
No,
start the
sir.
metallurgy.
Because
Uh,
my half yearly is already done. So we had acid bases for half yearly, but now that our second term has started, we are slowly having the revision for metals and non-metals, and it's in the unit tests. So that's why I was saying.
okay. So I will try. I will try in the 9:30 class. Okay. So you have to join in 9:30 at 9:30. Okay. It might be possible that we will do this one after Friday. This Friday
It's
means
okay, sir. It's all right. I was just informing because I thought
yeah.
maybe you skipped that topic.
No. I
And
have not escaped. I remember because half yearly exams of most of the students are not having their half yearly exams, and they are having their half yearly exams now. And
yes, sir.
this portion metallurgy is not coming in the examination. So I'm just revising the topic only that are important and that are coming in the examinations because it will be awkward for me and other students also, but because if they are not having this syllabus and I'm
Yes,
teaching
sir.
them. Okay, so after Friday, we will going to start that. Okay, or if you are having any test, then I will record the lecture for you. Okay, so you can inform me. Okay,
Okay, sir.
if you are having any exams in your for metallurgy, we can have the extra classes for you individually, and or we can I can record the lecture for you. Okay.
But for now, it's okay, sir.
Okay.
We can do it normally when you get the time.
Okay. So now this is now moving to the next type of question that is being asked on this one. That is washing soda. The uses of washing soda is that washing soda is used in many cases that it is used for manufacturing of glass. It is used for removing the permanent hardness of water. Okay, so noted down that washing soda is used in removing the permanent hardness of water. It is used for removing the permanent hardness of water. Okay. And means so many times it has been asked that a salt which is used for removing the permanent hardness of water. So you must know when it is said that permanent hardness salt it is being used for removing the permanent hardness of water. So what can be that salt? Okay, got it. So
Yes, sir.
this question, I think that I have done this question in the previous class. Yes, I have done this one, the previous class. Note this question. A compound X is bitter in taste and its component is of washing powder and react with dilute acetyl to give Briggs acceptance due to colorless, odorless gas which turns. Note it down. Note this question. Note this question. Done?
Done, sir.
So what is it? A compound X is bitter in taste. Bitter in taste means and is
It is
a
a base.
component. Yes, it is a base. And it is a component of washing powder. It is a component of washing powder and react with dilute hydrochloric acid. So it is a component. So the substance that we have studied till now in bitter in taste that is generally like we have the salts that is generally if bitter in taste salts means this can be baking soda, it can be a washing soda. But washing soda, if in the question it is being said that it is a component of washing soda. So it can be baking soda. Okay, because we know that baking soda has bitter taste. Because of that, to neutralize that bitter taste, we generally add tartaric acid or ethamidable acid to it. Okay, to make it baking powder. Okay, so if I talk about this one, it is a component of washing powder and react with dilute HCl. React with dilute acid. So what happened when sodium hydrogen carbonate, let's suppose, it react with dilute acid, what it will give you? Tell me. What happened? This is metal hydrogen carbonate. Metal hydrogen carbonate. Carbonate. When it react with acids, what it gives you? Tell me.
Salt plus
Salt plus
H2O plus CO2.
H2O plus CO2. Okay, so it is saying that it will give you salt, like it will give you which salt? Here, which salt will be given to you?
Sodium chloride, NaCl.
Yes, it will give you sodium chloride plus water plus carbon dioxide. Okay, so it is being said here that to produce Briggs effervescence due to colorless, odorless gas. Okay, and this gas is Y, which can turns blue litmus, sorry, which can turn lime water milky. So only lime water can be turned milky by using carbon dioxide gas. This is very famous. That lime water, when carbon dioxide is passed through lime water, it gets milky due to the formation of calcium carbonate particles. So this is gas Y due to the formation and due to the formation of Z. So this gas can convert lime water milky. So if I'm passing, this is calcium hydroxide. This is when passed through, or this carbon dioxide is passed through it. It will give you calcium carbonate, that is solid particles plus water. And because of this, the lime water turns milky due to the formation of Z. Z is calcium carbonate. Okay, got it? Got it? Got it now?
Yes.
Yes. Yes, sir.
Now, when excess of CO2, when excess of CO2 is passed, when excess of CO2 is passed through it, when excess of CO2 is passed, the milkiness disappear due to the formation of P. So when excess of CO2 is passed, so when this one, this is substance, this is calcium carbonate plus water plus excess of CO2 is passed through this. Okay, it is not saying excess of CO2. Excess of CO2 is passed through. It is not saying passed through Z. No, Z plus this water also. Okay, yeah. So when we are passing excess of CO2, this will get converted into calcium hydrogen carbonate, CaHCO3. Both twice. Okay, this is 2 hydrogen. This is 2 hydrogen here. This is 1 carbon. This is and 1 carbon here. This is 2 carbon. Okay, 6 oxygen, 3, 2, 5, and 1, 6, and 1 calcium, 1 calcium. That is balanced. Okay, so this is if I talk about you that milkiness disappear. Why? Because here this is aqueous form, or we can say that this is insoluble. This is soluble form. Soluble. This is water soluble. Okay. So when something that is water soluble is formed, so its color will not be appear, will not be visible to you. For example, if you have white salt and if you are dissolving this one into water, so the color of the water will not change. Okay, into white. Why? Because this goes into the intermolecular space. And why, if you dissolve some chalk into the water, it will becomes white in color. Why? Because chalk particles are not able to, they are much bigger in size and they are not able to go into the or take in the intermolecular space of the water. So the color of the particles will be visible to you. But if it goes into the intermolecular space, then the color will not be appear. So here the milkiness disappeared due to the formation of calcium hydrogen carbonate, and that is water soluble. This is water soluble, and this is insoluble. Okay. So if I talk to you what is X, so X is this one. What is Y? Y is this carbon dioxide. And what is Z? Z is calcium carbonate. And what is P? P is this calcium hydrogen carbonate. Okay. So note it down that milkiness disappear because of the formation of, let me write here each and everything, that when CO2 is passed through lime water, it's milky, it become milky, it become milky, due to formation of calcium carbonate. Calcium carbonate particles which are insoluble and white in color. While when excess of CO2 is passed, then this milkiness disappears due to the formation of insoluble, sorry, due to the formation of soluble calcium hydrogen carbonate. The formula for calcium hydrogen carbonate is CaHCO3 whole twice. Why? Because calcium has valency 2 and HCO3 has valency 1. And you cross multiply, it will give you CaHCO3 whole twice. Okay, got it? Calcium hydrogen carbonate, which dissolved in water. Write this all. Take note it down.
Done, sir.
So, have you noted this one also? You also, you also noted this one?
Yes, sir.
Tejasvi?
Yes,
Abhi?
sir.
Yes, sir.
Okay.
Done.
So, next question. Question going to question. Let's take the question from related to salt. So we have completed the topics from this source, each and every topic. Okay. This is question number 38. Question number 38. Salt A commonly used in bakery products on heating gets converted into another salt B, which itself is used for removal of permanent hardness of water. The gas C is passed.
Powder.
A is
Baking
baking
powder.
baking powder. Okay. In bakery products on heating get converted into another product B, which itself is used for removing the permanent hardness. So when you heat baking powder, what it will form? Washing soda. Okay. That is Na2CO3, which is used for removing permanent hardness of water. And a gas C is evolved. Okay. When you heat a gas C is evolved. In this gas C, when passed through lime water, will convert lime water into which is that gas C?
Carbon
CO2.
dioxide.
CO2.
CO. So this carbon dioxide. Simple that we are studying. That is NaHCO3 when heated. NaHCO3 when heated, it will give you Na2CO3. That is, this is A, this is B, and H2 plus CO2. This is C. Yes, okay. Got it? Understood?
Yes, sir.
Understood? Okay. So we will going to discuss some another class also. Okay. So you have to join at the salt portion has been completed. Okay, this is going to come in your examination. So let me explain. There is such thing that questions related to this one also. We'll do this one also. Okay, do this one. In one of the industrial purpose used for manufacture of sodium hydroxide, a gas X is formed as byproduct. The gas X react with lime water to gives a compound Y, which is used as bleaching agent. Find out the X, Y, and that we have discussed. Tell me. Tell me x, y, z, x and y. This is a simple question. X and y. What is x
X
and y?
CO2.
Yes, x is CO2.
Sir, it is chlorine gas.
X is CO2. Here it is said that in one of the industrial purpose used for manufacturing this sodium hydroxide. So sodium hydroxide is manufactured by chloralkali process that we heat. Sorry, when NaCl and water is electricity is passed through. Okay, so when electricity is passed through, it will gives you NaOH plus Cl2 plus H2. Okay, so gives a gas X. This is the gas X. Okay, this is Cl2, chlorine gas. Got it? Got it? That we have discussed in previous class. Gas X, which react with lime water to gives a compound Y. Which react with lime water. Lime water. So what is lime water? This is calcium hydroxide. And this when react with chlorine gas, it will give you CaOCl2. That is bleaching powder. Identify XY. Identify X, Y, and this is Y compound. Okay, got it? Note it down. Note the question. Dear students, your class will start at 9:30. The next class that will be a revision class, okay, for the numericals or some other stuff that we will discuss. Okay, so you have to join that one at 9:30. Okay, again. Okay,
Yes,
Yes,
sir.
sir.
Shweta,
Yes, sir.
are you there?
Yes, sir.
It's not coming to me.
Yes, sir.
Seriously, you speak something?
Yes, sir. Can you hear me?
No. Now speak.
Sir, can you hear me?
Yeah, I can hear you. So you have to join again at 9:30. Okay.